go. There you go. So here's the building that you guys are are dealing with. One more time. These are in the back of your book, so you should have all of them. The building that we have, guys, is a two-story building. And what we're doing, it's a multi-occupant, so there are different type of occupants, and we're to design a building, electrical power system for this building. To give you an idea, here's the architectural one for it. This is the basement blueprint. I want to bring to your attention, guys, that there is the area here. Beauty, say that one, S-A-L-O-N. Salon. I always call it saloon. Salon. The beauty salon is here. We have a bakery, and we have an insurance office. So it's multi-occupants. Why do I like this project again? The design project that you guys are doing with me, it's one occupant all, so we don't have to worry too much about metering, right? Like we did in a residential building. Do you guys remember how we did different meters for different apartments? When you have a commercial building with different occupants, you have to have a meter for every occupant. So that's a different way of doing business. The project that we have right now that you guys are working on, your project, good morning, Brian. Your project is one occupant commercial building. You guys, the one that we did yesterday, the one occupant. So we care about 1 meter for the whole occupant. This building is multi-occupant. So just FYI, the project, the commercial project, guys, follow this building step by step, and designing a lighting and a power and a low voltage system for this building, chapter per chapter. Okay, so when they ask you to refer to the blueprints from this book, they're asking you, go to the blueprints, they're asking about these blueprints at the back of the book. Everybody understand that one? So I'm not going to go through the architectural one. What do we care about the architectural one? Why do we like architectural stuff, guys? The good thing about architecture, when you have the architectural blueprints, it will give you more details about the type of the building. Is it type 1, type 2, type 3, type 4, or type 5? Based on the type of the building, Brian, you can use certain wiring methods, and you shall not use other types of wiring methods. So this is a commercial building. It looks like it's a concrete commercial building. So most likely it will be type 2, and then we're going to be using, if it's a type 2 commercial concrete or masonry building, the type of the wiring method that we use, guys, is EMT conduit and MC cable. EMT conduit and MC cable. The building that we're dealing with is also, it's a concrete building. We're going to be using type 2, called type 2, and we're going to be type 1 or type 2. And we're going to be using an EMT conduit and MC cable. Why this is so important? There's so many wiring methods, guys, and based on the type of the building, there are certain wiring methods approved and others are not. Okay, so just a quick reminder, this is the basement of the building. I want to remind you, the basement is shared between 3 entities, the beauty salon and the bakery and the insurance. Everybody can see that? These are the 3 locations that shared, the basement is shared between all these 3 locations. There is a stairway that goes all the way up. So that's number 1, A1. Any comments, guys, about A1? So that's architectural one. Let's go to A2. A2, the first floor. The first floor, the same thing. There's a drugstore. In the first floor, there's a drugstore. The bakery continues. And so in the second building, we have a bakery kitchen, and bakery store, and a drugstore in the A2. Okay, so multidiscipline. There you go. A3, we have the beauty salon and the real estate. There's a real estate office here. And there is the insurance, That's kind of an interesting. The insurance. So that's these are the 3 second. This is the second floor. In the second floor, guys, we have the insurance office, and it's shared with the beauty salon and real estate office here. So these are all multidiscipline areas. that we're supposed to design. What are you? Can you guys see where there's a common hallway here between all these places? There's an elevator. There's a men and women bathrooms here. So all these are common places that need to be fit. So why are we doing this? You're going to be, Karen, you're going to be walking into a building like this, and they're going to ask you to design a power system and lighting and low voltage for a multi-occupant building. The first thing you're going to ask yourself, what's common between all of them, right? What is common between all of them? So we can put them in the house panel. And what's not common, so we can put them in separate panels. So what's common is the hallways and the bathroom common between all those occupants and the elevator. These are all common, so they have to be in a common panel. Everything else, from the salon into the real estate, into the insurance office, these will have its own panels and its own meters. Did you guys see why it's important to know if it's multi-occupant building, every occupant is going to have its own meter. That's really the key point. Okay, so that's basically that's what you're building. This is how it looks like when you have an elevation view of it. This is how it looks like from the east. Two-story building with a basement. Two-story building with a basement. There's another. This is west elevation, and this is how site view. That's the site, how it's going to look in the site. That's how the building is. So if you guys are to design a parking lot light, these will be the parking lot slots as well as the parking lot light that you are to install for this building. So the building is 43 feet by 60 feet, two-story building with a basement, concrete. Okay. Any comments, guys? Any questions? This is where the building is located. Two elevation of this building. Look at the building, guys. The height of the first floor is 10 feet 4 inches. Second floor is 8 feet 6 inches. That's the finished. That's up to the finished ceiling. And again, there are also a space here, probably a couple of feet here where you can put your mechanical equipment. Here's the basement. The height of the basement is 9 feet 0 inches. Brian, there will be questions on the test. We'll ask you about what's the height of the basement and so forth. So why it's important to look at the architectural stuff, guys, it will give you an information. For example, when you do takeoff, electrical takeoff on this project, elevation are a big deal. I'm going to go through the wall. How long of an EMT conduit do I need to put through the wall or an MC cable? Well, it depends on the height of the wall. So you can see why it's important to know the elevations of the building. In Revit, the nice thing about Revit will give you the third dimension, so you'll always be going to be looking at the third dimension. Okay, I want you guys to assure me that you understand A1 through A4. So it's a commercial multi-occupant building, two-story with a basement. The 2 stories and the basement are shared between, I believe, 5 occupants. And we need to design a power and lighting and low voltage system for this building. When you are faced with a question like this, the first thing you need to ask yourself, what's the common between all of them? So we're going to go put them in a common panel. And what's not common, so we can put them in the individual occupant panel and meter. Cool? Any questions, guys, about these questions? So when we go to Revit and see elevation, Revit is going to be doing elevation. You know what elevation is. When you have an east elevation, guys, you're looking at the building and taking from the east and looking at the view of the building. West elevation, you're standing in the west and you're looking at the building. East elevation, standing in the east and looking at the building, right? Everybody knows what the elevation. Plan view or side view, you're standing right like a bird's eye. We're at the top and looking at the bottom of that building. You guys have not done architectural. We're not architectural students, but it's so important to understand the elevations, the sections. There's something called elevation of a building. When you have east elevation, stand in the east, look at the building, and that's what you see. West, stand in the west, look at the building. North, stand in the north, look at the building. South, looking at it from the south. Side or plan view, you're looking at it from the top. Everybody understand that? Did you guys do geometry in school and looking at all this stuff? So everybody understand that one. Site plan is looking at not just the building, at the whole site, how the building is located into the lot that the building. Okay, so we're good. Because these are the terminology that you're going to encounter as you go through in every project. You're going to be encountering the elevation. Architects, they give you tons of elevations. Okay, so we know what the site plan, we know what the elevation are, different elevation. Give us, what's the good about the elevation? Give you the third dimension. In Revit, the building is built in 3D. So later on, if you want to look at the elevation of the building, no problem. Go to one of these views, I'll show you, and you can see the elevation of the building. Okay, any comments, guys, about these architectural? Any comments about these architectural ones? So let's go to the third one. Now this one is commercial project. These are sections. These are, I believe, sections. South is no, south elevation and north. I'm sorry. These are the south and the north. I want to bring to your attention, guys. Look at this here. Can you guys see exterior lighting? They show the exterior lighting here. So what's in it for you? Your exterior lighting is going to be mounted. Do we have the mounting height for the exterior lighting? At this level, which is finished floor second level, its elevation is 218.33. 218.33, and the floor, that point elevation here is 208. So to find the difference between where your fixture is going to be located, when you measure, all what you have to do is just subtract 218. This is the elevation above the sea level. The way the architects do elevations, they don't tell you the height is 10 feet. One way of doing it. The other way is they go to the top and they say this is, for example, that is 218.33 feet above the sea level. Everything is measured based on the sea level, right? I think in Minnesota we are, what is it, 800 feet above the sea level? Most of the places here in the metro area. Is it something like 800 feet above sea level? So if they give you 2 points, and each point is measured at one elevation. So this point is, I don't know if you guys can see it here, at 218, and this point is 207. So all what you have to do is take 218.33, subtract from it 207.83, and that will get you the elevation of this building. Can I have thumbs up, Chad? We know how to do that. What's in it for you when you're doing estimating and takeoff? It's very important to know how to find the elevation of the building. These numbers are based on the sea level. So elevation above the sea level. Okay, so here's my lighting fixture. So I can find the height of my lighting fixture. So I can send my electricians there to mount it at the right height. Don't you think it's important? So here's, you can see your lighting fixture in this here. This is my north looking from the north of the building, south looking from the south of the building. South elevation, I have also exterior lights. That's what you guys are going to be mounting, exterior lights for our commercial building that you're going to be designing. You will be putting security exterior lights around the whole perimeter. So that will give you, what this project is meant, guys, is to give you an idea how to design a building. Here's another example, right? Here's another example how to put the exterior lights. Okay, and there's you can do the elevation, find how the the building is mounted and oriented and so forth. Any question, guys, about the elevation? North, south, east, west elevation. Plus, they're giving you the floor plan for the basement, view for the first floor and second floor. These are your architectural stuff. Okay, let's go to the last one. The last one is sections, cross sections. Cross section AA. Can you guys see? So cross section is, imagine Matt grabbing a saw and saw off half of this room. And then take one half, throw it, and look at it. Did you guys done that? Anybody done drafting in school? Did you guys do drafting? You done drafting? So that's what a section is. So for example, here's my code book. Saw that by half, take one half, throw it, and look at what you see after you took a half. That's what elevate. Who cares? Why do they do cross sections? The cross section guys let you see what's inside the building. Views will get you to see the building from the outside, how it's going to look from the outside. Section allow you to see the building from the inside. Very important thing about sections. You guys will be doing with me sections. We're going to be doing sections for the building so we can do our rises. So it's so important, guys, the sections when it comes to the section. So for example, section AA, let's go see where section A and AB, look how it shows the stairway, shows the interior doors, and where they're located. I don't know where they should be in one of these. Here you go. Section A at A6. Can you guys see where section A here? Here's where they're cutting. They saw the building right there. There's A. Where's B? So here's section B. So what they're doing is they're cutting the building this way, section A, and this way, section B. You can see that? And then they're looking, after you saw, they're looking at what they can see here and what they can see here. Can I have thumbs up, Chad? We fully understand what a section is. Okay, what's in it for the section, guys? It gives you more details about the interior of the building. We don't do sections as electrical engineers. The architects do sections, but we are in the construction industry. So you know, when you have a construction industry, guys, here's a construction pie. You, with all the respect, we, the electrical design, are this piece of the pie, 10%. With all the respect for all of what we do, we're only representing, guys, 10%. When they build a stadium, or a hospital, or a commercial building, the amount of dollars they're going to get out of that building, you as an electrical designer, not a construction, as electrical designer, is 10% of that dollar. So if the building costs $100 million, you get electrically, you'll get 10 out of them. The construction ones. So and if the fees for the engineering is 100 million, say $10 million, you'll get 1 million out of them. The fees for that. So we are 10% of the engineering and 10% of the construction. If you're doing construction like work for Parson, typically you're 10% of how much the building is going to cost construction-wise. If you're doing Mashad Kuliks and doing the engineering, take the engineering fees for all the architects and the engineers, all different. The electrical portion of it is 10%. Do you guys see how important for all of us? No. What happened to the other 90%? Other disciplines. Do you think it's important for us to coordinate with the 90%? Don't you think so? So just to put things in perspective, guys, the construction industry is a big industry. You're only one little slice of that big pie that's called the design and construction industry. One little slice. What happened to the 90%? That's your concrete, masonry contractors, the architects, the interior designers, the mechanical engineers, the environmental engineers, the structural engineers, what else? The roofers, the sheetrockers, you name it. And you guys, you know what the construction is. There's all the other disciplines. So that's why it's important for us to know all these sections. We need to coordinate. The architects drive us. So whatever the architects do, the model that you guys have is an architectural model. So this will be driving us. Okay, so these are the two sections that give us more information. So as you answer the questions on the book, when they refer you to go find information in the plans, can I have thumbs up, Chad? We know which plans to go to, right? These plans. Okay, so these are the architectural ones. There's all the way, 5 of them, 6 of them. Now let's talk electrical. Now they give you 6 sheets of architectural for this project. How many sheets? 6 sheets of architectural. And then the author of this book, great gentleman, and what they did is they took the building and they designed a power, lighting, and low voltage system for it. So why do you think Chad is bugging you with this book then? Brian, my friend, this is another example for you, and now you have a few other examples, to how to do a commercial building. The reason why I like it, because it's multi-occupant building, this book. The one that I ask you guys to design is only single occupant. What's the difference? 1 meter feed the whole building, multiple meters feeding separate parts of the building. That's the only difference. Right? So the light of this insurance office cannot be fed from the lighting circuit here. If this is the insurance office, the lighting circuit cannot be feeding also lights in the hallway, because the hallway is a common place. Cool. Can I guys get you to understand the difference, why this is so important? Okay, let's look at the first one, the basement. Let's look at the basement. In the basement, E1 is the basement. Let's just look, and I want to go over these guys in details as we reach them. So they're having light and power and low voltage all mixed in one. They don't have sheets for disciplines. They have light, power, low voltage to one. So I have air handler here with circuit B27 and 31 feeding it. I have a receptacle. B3 is feeding it. Circuit B3 is feeding it. I have a couple of lights. They're type B lights. So all these equipment are circuited. Can you guys see that? So what's in it for you? These are ideas how to circuit your project. That's how the basement is circuited. Just a quick reminder, if it's a bakery store, you shall not feed anything from the beauty salon from a circuit that originated in a bakery store, right? You can't do that. They're two different disciplines, okay? Can you guys see the hallway here? All these hallways are common places, so they will have a separate circuit. They have a three-way switch that turn all of them on and goes all the way down up to another three-way switch. Water heater, B12 through 16 is feeding this water heater. Utility sink, here's a panel. Baseboard, that's my panel. Auto transfer switch, they have it sitting in here. So, and again, we will be getting into this one, guys, as we go through the chapters. We'll be getting a little bit into how they did to do it. So what's in it for you? What's in it for you now is here's another example of how they do a commercial building. For example, look at this here. They are having the horn strobe here, right in here for the security system. So we have all these in one. So that's your electrical system in the basement. Again, we'll go over these in the chapters. Now moving into first floor. Now the first floor, we're going to continue with the drugstore here. Here's my light. Can you guys see these are back-to-back lighting fixture? Instead of separate lighting fixture, you've seen them if you go to Menards or whatever, they have them back-to-back, feeding one to the other. That's the lighting fixture that they're using. These are really cool. They're fixture I, and these are switched from switch A, B, C, A, B, C. You know what they did here? They took, taking this fixture is going to be on switch A, switch B, switch C, switch A, switch B, switch C. That will give you an idea when you guys put your lighting in the commercial building, how to switch them. A good idea is to have at least multiple levels of switching. They're having a low voltage panel here, lighting control panel, guys. We'll talk about this one, but they're controlling them from a low voltage control panel. So they have a 24 volt switches to control these lights via a relay. That's how they do it. You guys will be doing the same thing for Chad when it comes to lighting. So if you study this, you're ahead of me when it comes to lighting, because we're going to do the same concept for our lights. Here's your phone data is right here. So remember, these are all in one. Here's your, they're having the exit signs here. You see the exit signs? We're going to be doing exit signs, exactly. So that will give you an idea, guys. All the exit signs, right? And again, I'm not going to get into the lighting yet because it will be coming. Just give you an idea when you look at them. Here's GFCI receptacle in the bathroom. We have lights coming, 2 lights in the bathroom here. It looks like 3 lights, and so forth. So these are, and some of them, lights and receptacle and low voltage for every discipline. Look at the way they did them here. They did so they're piping them all the way. It's a fixture C. That's what they're using here. The C stands for fixture C. And they're all coming from a 4-way switch. These guys are high voltage 4-way and 3-way switches. They're turning them on and off. Toilets, they have some fans and lights in the toilets like they did in the other one, and GFC receptacle. I believe these are, can't remember, these are light. I believe the 2 lights and a fan. I believe this is a fan here. Okay? So that's an already designed project for you in a commercial building. What's in it for you guys? You're going to be following it and getting ideas how to design it. So if you go work for Parsons Electric and they have a multi-occupant commercial building, what do? Oh, I did one with Chad. And they say, go give it a shot. Yeah, go circuit it. The first you're going to ask yourself, what are the common places? So I can put them in a house panel. And the non-common places, I'm going to put them in a separate panel. That's it, as simple as that. Any comments, guys? Any questions? Comments, questions? And I'm not going too deep into the circuiting because that's coming. As we go through, we're going to be referring to it. This is just overview. Can you guys see where they put the AC unit here with the disconnect? Isn't that what you did with the Chad? Disconnect for 14 through 16, 14, 16, 18. Why do they have 3 circuits, guys, for it? We're dealing with 3-phase. This system is 3-phase system. Okay, so let's go to E2, E3. E3 is the second floor. The second floor, guys, the beauty salon. is having all the, look at that quad receptacle GFCI. You can see in the salon they're going to be having water, right? So water, GFCI. You have a fixture F here, a lot of other fixtures, so people can see you when they're sitting, so they can give an idea. This is where you sit here, you cut your hair, Adam, and they put all these lights on you so you can feel good, right? When they do shampoo your hair and all this good stuff. So you can see they need more lights to see and cut. So they're putting more lights. Can you guys see that on every place? So you can see how every area is different. Same thing for low voltage. We have, then we go to the real estate office, bunch of nice lights here in the real estate office. There's an elevator that's going to be here. Elevator control panel, another panel board here to feed certain systems. In the insurance office, those guys are cooking a lot of information here. So look at the phone and data offices with a lot of quads. This quad is a 4 receptacle, 2 duplex. Can you guys see how they put a lot of quad receptacle there? When it says IG is insulated ground, because they're crunching numbers for your insurance so they can charge you and charge me and all stuff, they're having an insulated ground, guys, so they don't corrupt the data. We'll talk about insulated ground receptacle, commonly used when you're crunching numbers and when you don't want to interfere with the operation of your data. Insurance is a good example, banks, any place where they crunch numbers and store data. Okay, so you can see what they did here. These are phone data floor. These one are they dug a hole, not dug, but they have a box in the floor with a conduit, and they cut the box, not cut the box. The box come designed in 2 sections. One section they put the low voltage in it. The other section they put the high voltage. I want to bring to your attention, guys, this one the exact one we're using in our project. We're going to have a box, literally a box exactly here, where you're going to have a receptacle in one side and a low voltage in the other side. So here's another example how you do it right into the floor. So when you guys designing power, not next week, the week after, when you start laying out our power, when it comes to the cubicle and the open office, the option that we're asking for, I think it's the best option to wire it. There's other options. What are the other options? Here, you're looking at. They call it pole poles. Bring a pole pole. But do you see how ugly it is, guys? How they're coming down. It's not good. That would be a great idea if we came from the bottom, right, and fit it, so you don't have to see all these poles standing in the office. So when you have an open office like this, could be considered an open office because you have to wire data and phone here. 2 options: either you come up with a power pole right here, or you come from underground with typically one junction box split into 2, one for the low voltage, one for the high voltage, and you have a flexible non-metallic or flexible metallic conduit, liquid tied to the furniture, and that will take the data and the phone separately into different channels inside the furniture, and that's how you get when you sit in a cubicle. You have a cubicle, right? That's how your cubicle is wired. They buy a wired furniture with devices, and they tie at the end in a junction box to that furniture. What's in it for you, Karen, is when you have an open office and you start laying out your receptacles, and if you put receptacles and phone into the cubicles, you're not paying attention to each other. Right? We don't do that. Why? Because the furniture almost always, your furniture are wired. So if you have an open office with cubicles in it, that furniture, you're going to feed it from a junction box, multi-circuit coming and feeding the whole furniture, and the furniture will be interconnected with each other. Okay, so that's what they did here. Any comments, guys? Any questions? Questions about that? So what's in it for you? Like I said, is really great, great ideas to pick, to design. I want to bring to your attention, guys, to this fixture. It's called the EM on it. This tiny little fixture. This is a common hallway. Common hallway, the building code require you to have an emergency light so people don't panic. Public areas require emergency light. These could be backed up by batteries, so if we are to lose the power intentionally or unintentionally, locally or globally. Intentionally, Chad is tampering there somebody's tampering with the panel there. Unintentionally, short circuit here happened. Locally, that thing is happening right at Dunwoody. Globally, it's a storm hit the transmission line. We lost power outside our jurisdiction, right? All these, when you lose the power, the building code and electrical code require you to have an emergency light because people panic, and when they panic, it affects life safety, people's life safety. So these fixtures have to come within 10 seconds. So typically they put them either on a generator with an auto transfer switch, like we explained in the residential, or you can put them in a battery with a tiny little relay. When it loses power, since the power has been lost, flip you from the power coming from the grid into the power coming from the battery or the generator. We will be doing the same thing for this project that you guys are working on. So what's in it for you? Here's another idea. How to do the emergency when you guys do light. When you're done with your light, you're going to ask Chad, where's your emergency light? Right? Where's your emergency light? Exit signs. Can you guys see that little guy? That's an exit sign. When you have a commercial building, guys, the code requires you to lead the people safely out of the building upon the existence of an emergency. How do you lead them? You need to tell them, I have no idea what your building is. I don't know. There's so many doors. Which one of them is lead me outside the building? Exit doors will safely lead the occupants, the public, safely outside the building. You can see them all over here, Dunwoody. And any commercial building or multi-discipline residential building too, they have to have a sign that says exit sign and point to the direction of the exit. Either right at the top of the exit, or it has to point to the direction of the exit. So this one will be pointing to the direction of the exit, wherever the direction of the exit is. Any comments, guys? Exit signs and emergency light. So typically they call them bug eyes. You see them all the time in smaller offices. They have an exit sign with little lights on it, right? And it will lit if there's an emergency. The sign is there. We have battery in it, so it tells you where the exit is. And not only that, but it also lit the exit for you. When you lose power, the batteries will power these little lights for an hour or so to safely evacuate the building. Safely evacuate the building. You're dealing with the building code. So that's what you're going to be dealing with. Any comments, guys? Any questions about that? Comments, questions? So I'm picking, and again, picking certain things from Matt. Anything?
What about the elevator that the
Yes, certain elevators. Depends upon the building code. I believe it's 3-story building or 4-story building require you to put one elevator on emergency. You have to have a generator on it. I think if it's less than 3, and also tied to the building is the building. Yeah, it's this. I think it's less than 3 or 4. I can't remember. You don't have to. But more than where are we here? We're 3 at Dunwoody. We require 1. So 3. I think 3 or more required to put them one elevator. Not all of them. At least 1 on an emergency generator. So 3 or more, I believe. So if less than 3, then you don't have to. And all these will be decided by the architects. I mean, is it less than 3 or 3? At the beginning, the architects will decide, with our engineers, when you sit around, this building requires an emergency generator. Yep, so we'll provide the emergency generator for them. So typically the emergency lights, guys, exit signs, egress lights, and elevators for most of the building. If you go to the hospital, it's a whole different area. They have receptacles also in the emergency system. They have heating and cooling in the emergency system because people are sitting there. They can't leave. So, okay. So please use this one, guys, as a way of finding, showing another example of showing lights. Can you guys see how we do it in the commercial building? Smoke detectors, they're showing it here. Okay, so let's go to I believe, the second. The last one. So here's you go. We did the basement, and we did the first floor and the second floor, light, power, and low voltage. Now the last one, guys, has all your panel schedules. I'm going to walk you from the top. So from the top, can you guys see the first one is for the bakery? The bakery has a 208 123 phase 4 wire, 400 amp panel. And can you guys see here's all the loads fed from the bakery. I want to bring to your attention, guys, the dishwasher. They have a dishwasher, 30 amp. Can you guys see it's 15, 17, and 19? What would that tell you? It's a three-phase, right? It's a three-phase. Oven, 21, 23, 25. That's a three-phase, right? How about heater in the basement? Basement heater, 33, 34, 35, 37. Look at the spare at the bottom. And also on this side, the even ones, I have luminaires, 20 amp circuits. They're 120. Look at the interrupting capability of this panel, guys, 24 kiloamp. Fed from the main service. It tells you where it's fed from. Location, wall near back door. And is it flush or surface mounted? This one is flush. Adam, this is exactly what you guys did with me on the residential project, except they're three-phase panels. Can you guys see that? Okay, so here's one for the bakery. This one is for the drugstore. And this one is for the insurance office. And I have one for the beauty salon. And this one, no, salon. And this one for the, here's the owner. This is my favorite. Panel for the owner. What's the owner? That's the common place. The owner is the common place. So the basement and outdoor lights. And I have space heaters in the toilet, sump pump, elevator circuit feeder. All these are fed from where? The owner. So I have 200 amp panel, 28, 123 phase, 4 wire, feeding the owner. Then I have the real estate office has its own 100 amp panel, and the beauty salon or salon has its own, and the drugstore. Okay, so these are 1, 2, 3, 4, 5, 6 panels. Any question, guys, about these 6 panels? 6 panels in this building. Okay, this is how the bell, if you guys look at this corner, that will tell you how the feeders are located. I have feeder going to the beauty salon. And here's the switches for it, the insurance office and the real estate, right? The bakery, the drugstore, and the owner. All these are your 6 disconnect means. They call them 6 disconnect means by the NEC code book. We'll talk about this one later too. Okay, here's the riser. Can you guys see the last thing is the riser or the one-line diagram? The way, I want to emphasize this one a little bit. The way they did this project, guys, they brought the power from Excel into a gutter, and they tabbed from this gutter. They tabbed it. 6 disconnects. Can you guys see the 6 disconnect rule? I have a disconnect here. 2, 3, 4, 5, and 6. 6 disconnects, right? And we're tabbing them, and we're feeding different type of loads. So I have the beauty salon, I have the bakery, I have the insurance, the real estate, the drugstore. Then what they did, guys, they have also the owner panel. I want to emphasize the owner panel came into an auto transfer switch through a generator. And then here's my owner panel and fit the elevator and the elevator equipment, plus a couple of other things. So the owner panel, because it's going to be feeding the emergency loads, they put it on a generator. Lights, exit signs, as well as an elevator. Can you guys see that? So what they did, they call it 6 disconnect rules, Matt. You haven't been talked a little bit. We'll be talking about it code-wise. 6 disconnect rules is you can have 6 main circuit breakers feeding a building, no more than 6. Any comments, any question, guys, how the building is fed? They took a transformer and they bring it to a gutter. They tabbed these wires, tabbed them, 3-phase, 4-wire, and they fed a meter. Anybody knows why they have a meter here? Can you guys see? Everybody pay attention to the meters in here? So they need to charge you. So each one of those occupants have its own meter. You think so, right? Meter, either direct meter or through CTs if it's bigger than 400 amp, 200 amp. All the 200 amp are directly metered. The 300 amp here is metered through CTs. They call them CTs. Any comments, guys? Any questions? So this is an example. of how do you do a multi-occupant commercial building. Multi-occupant commercial building. And Brian's buddies at Excel, they will come and they install all these features so they can charge you, so they can pay Brian big dollars, right? Or the others. Any comments, any questions? Why would you do it this way, guys? Multi-occupant. Now, Matt, had this building been owned and operated, not owned, but operated by one building, one office, you don't have, do you need all these meters? Like the building that we have, it's going, how many meters we're going to have for it? 1 meter. And then at the bottom here, give you the sizes, guys. I don't know if you see it. This is 200 to 150. The size of the surface, 150, 100, 150, 150, 300, and 200. So all these are the size of the surfaces. The size of the surfaces. The overall size, it looks like 1,000 amp worth of power coming to this building and split two different directions. Okay, service conductors. And then at the bottom, guys, it tells you how they size them. We have a service conductor, 3 trade size. Here's a conduit, metric designator with the following conductors and a ground. 3 sets to carry the service conductors. And then they went into each one of these loads, each one of these loads. Any comments, guys? Any questions? Any comments? Any questions? You guys will be designing. I'm just going to bring this one to your attention a little bit at the bottom here. Can you guys see the numbers? Okay, I want to bring to your attention this. Okay, how am I going to the best application here? And for your riser, when we build the riser next week, you will be required to do exactly the same. Tag it, build it like this, tag it. Underneath it, you're going to have something called feeder schedule. Here's what 1 means. This is the feeder that we're sizing. It's a service. There are 3 runs of 2.5 PVC conduit. Each one of them will have 3 conductors, 450 for the 3-phase, and 1 conductor, 1 aught for the neutral. Where are you guys going to get these sizes? From what your friend Chad is going to walk you through in a few seconds here. Walk you through how to do the calculation. Then you can go to, let's go to number 5. Here's number 5. Number 5 is actually 150 amp service. Here's my number 5. It's going to the drugstore. It's a 1 conduit EMP conduit. I am pulling 3 conductors, 1 aught, and 1 conductor number 4. These are for the 3-phase, and this is for my neutral. Any comments, guys? Any questions? Any comments? Any questions? Any comments? Any questions? Does it make sense? Is it too much? Too little? So you guys will be providing a power system for this, very similar to it. The only difference between our project and this project, guys, that we're using, it's called one-line diagram of service and feeders. One-line diagram. The only difference is the one that we have is going to have only 1 meter. It's going to have only 1 meter. Okay, any comments, guys? Any questions about this? If you want to be, guys, a good designer, here's another example for multi-occupant commercial building. With the example that you guys did with Chad, we will be doing in a single occupant commercial building. Hopefully that will get you there. I want to bring to your attention that we'll be doing this one, guys. This one here, this one, number 8, is a grounding electrode conductor. You will be required to size a grounding electrode conductor. So it's a 2 aught going to the metal pipe with 4 jumper to concrete in-case electrode. Water pipe with a 4 number EWG jumper to the concrete in-case electrode. So they have a 4 aught going to the water and then jumped into the attached to the concrete in-case electrode. So we will be sizing this one for the building as well. Any comments, guys? Any questions about this project? Does it make sense? Yes, Karen? So Where would you use a system like this, guys? You use a system like this if you have multi-discipline. Another alternative for sizing this project, guys, the way they did it is to have a meter center, and they have them, and you have a meter center 1, 2, 3, 4, 5, 6, like we did in residential. And from the meter center, you come up with a circuit breaker, and you go to or fuses, circuit breaker or fuses. Let's do it this side. And your power will be coming directly from here. So what's the difference between this box and these little individual disconnects here? So you can see these are just little disconnects and a separate meter. Cheaper, right? I can put the fuse, this one here will be equivalent to this. So two options, either a gutter where I can tab a meter socket and a fuse disconnect, three separate entities, three separate boxes wired together, or one big box bust together, and all I have to do is just tab into the feeder from each one of them. Either this will be a better design here, right? All controlled in one location and so forth. What's the disadvantages? A little bit more expensive, the equipment. Any comments, guys? Any questions about designing a power system for a building? Any comments? Any questions? So do me a favor, my friends. We will be referring to this one as we go, guys, through the chapters. It's a good project. Since we're doing riser next week or the week after, I would like you guys to look at this riser, especially this one, and that's how, and please study this, and that's how we're going to build our riser in Revit. Similar to what we're going to do in Revit. Similar to what we're going to do in Revit. Any comments, guys? Any questions? Now, with this, having said that, what I'm going to do next, guys, is I do have a load calculation for you, PDF. I want to give you 5 minutes to stretch, do something, get coffee, and I need to walk you through how to use the load calculation. So that will, so Matt, what you can do today is you can start building your load calculation right from the get-go. Cool? So we have 5 minutes? Let's do 5 minutes. Thank you.